You have been lied to about weight loss, and the truth is stranger than fiction itself. Where does fat actually go when your body finally starts burning it away? Does it melt into heat, drip out as sweat, or vanish overnight during strict dieting weeks? None of that is true, and the real answer will genuinely shock you today. Most of the fat you lose leaves your body silently, invisibly, through something you do every second. Every single breath you exhale might be carrying pieces of your former fat cells away. Yes, you read that correctly, and it gets even stranger from here. We're going deep inside the fat cell to understand this hidden process completely. Why does some people lose weight fast while others hit invisible walls? Why does weight come back so quickly right after you thought you had won? Fat cells do not simply vanish when your body becomes leaner and smaller. They shrink quietly, sit patiently, and sometimes seem to remember their old size. Today, we're breaking down 6 powerful biological switches controlling this entire process. These switches are breathing, insulin, leptin, stress, fasting, and fat cell memory itself. Once you understand these 6 systems, you will never see dieting the same way again. You will stop seeing weight loss as a simple calorie counting game forever. Instead, you will see it as a complex negotiation with your own biology. Here is the first surprising truth most people never learn about their bodies. When you lose weight, fat cells do not disappear from your body completely. They do not evaporate, get deleted, or leave politely like departing party guests. Most fat cells simply shrink down while quietly remaining exactly where they always were. Imagine each fat cell as a small storage container built for energy. When you gain weight, these containers fill with fuel and expand outward. When you lose weight, your body drains fuel from these containers, making them noticeably smaller. But the container itself is still sitting there, patiently waiting. This single fact explains why maintaining weight loss feels harder than everyone expects. Your body does not only track today's number on the scale, it carries a biological memory of the size those cells once reached. If a fat cell was once full, it may drift back toward fullness easily. This happens when you relax too fast, eat irregularly, or sleep poorly again. So weight loss becomes a 2-part mission rather than a single victory. First, you shrink the fat cells, then you keep them small long enough for your body to fully accept this brand new weight range. This is exactly why the maintenance phase deserves just as much respect. It is not some quiet afterthought following your difficult weight loss journey. It is the second, equally demanding biological battle you must fight. So where does all that fat mass actually go when burned? This is the part that genuinely surprises almost everyone who hears it explained. Fat does not melt into heat or leak silently out through sweat. It does not mysteriously disappear after a few intense workout sessions either. When your body starts using stored fat for energy, something fascinating happens. Large fat molecules break down into smaller components through a process called oxidation. Your body takes carbon atoms from fat and combines them with oxygen. This chemical reaction produces 2 final byproducts, mainly carbon dioxide and water. Here is the truly fascinating part that most people never realize consciously. Most of your lost fat mass leaves your body through your lungs as CO2. A smaller remaining portion leaves through urine, sweat, and simple moist breath. So if you believed sweat was literally fat dripping from your skin, reconsider that belief now. Sweat is mostly your body's built-in cooling mechanism, nothing more mysterious than that. Your breath, however, is the true major exit door for lost fat.
Picture your lungs functioning as your body's quiet, constant export gate for waste. Every time you walk, move faster, or simply breathe more deeply, something happens. Your body pulls carbon fragments from old fat storage sites immediately. It packages these carbon pieces into carbon dioxide molecules efficiently and quickly. Then, it sends these molecules out into the world with every breath. You are not just breathing to stay alive during active fat loss. You are literally breathing to physically move excess stored energy outside your body. Movement plays a far bigger role here than any fitness tracker suggests. When you sit still for hours, your body still breathes and burns energy, but your metabolic rate and lung airflow both remain relatively low and sluggish. When you start brisk walking, climbing stairs, or simply moving throughout your day, everything changes. Your muscles suddenly demand more ATP, the tiny fuel packets that power movement. Producing ATP from stored fat requires oxygen, and oxygen demand rises immediately. Your breathing naturally becomes deeper and faster to meet this rising demand. This brings more oxygen inward while pushing more carbon dioxide outward simultaneously. In other words, you are not simply working up an ordinary sweat here, you are actively increasing the transport flow of your entire carbon export system. Picture stored fat as old warehouse boxes stacked and filled with carbon. Movement essentially tells your body to open that warehouse door immediately. It breaks down the boxes, loads carbon fragments onto internal transport vehicles instantly. Your lungs then become the final exit gate for these carbon dioxide packages. This explains why simple daily activities matter so much more than people realize. Brisk walking, post-meal strolls, and light, consistent movement all genuinely count toward this. Breath is not just some passive side effect that happens during exercise sessions. In fat loss specifically, breath becomes an active, essential part of the exit route. Every deeper breath you take gives your body another chance to release excess energy. The first biological switch determining whether fat can actually leave cells involves insulin directly. Most people only think of insulin as related purely to blood sugar regulation, but in the story of fat loss, insulin acts like a powerful storage lock. Fat gets stored as triglycerides, large fuel molecules that cannot move freely alone. To use them, your body needs special enzymes that function like molecular scissors precisely. These scissors cut triglycerides into free fatty acids that can finally leave cells. But when insulin levels rise, these cutting scissors get suppressed almost instantly. The fat cell receives a clear signal that new energy is currently arriving. Imagine insulin as a strict security guard standing directly outside the fat warehouse. When insulin levels rise, this guard locks the storage door firmly and politely. You might diet hard, exercise consistently, and genuinely try your absolute best daily. But if insulin keeps spiking from constant snacking or sugary drink consumption, nothing changes. That storage door becomes significantly harder for your body to ever open. This explains why spacing out your meals matters far beyond simple willpower discipline. It gives insulin enough time to drop, allowing fat cells a genuine chance. A genuine chance to finally unlock their doors and release stored fuel outward. Why exactly does frequent eating make these internal molecular scissors far less effective overall? Picture a tiny team of cutters living inside every single fat cell you own. Their entire job involves breaking large triglyceride molecules into smaller, usable energy pieces constantly. When your body genuinely needs fuel, this cutting team springs immediately into focused action. They slice stored fat into fatty acids and send them straight into your bloodstream.
But here's the frustrating catch. This cutting team cannot function under high insulin. Every time you eat, especially refined carbs or sugar, insulin rises sharply again. And when insulin rises, your fat cells receive one crystal clear, unmistakable message instantly. Close the storage door immediately, because stored fat is not needed right now. If you eat breakfast, sip sweet coffee, snack constantly, then eat lunch and dessert, watch closely. Insulin barely gets any real chance to drop back down naturally throughout your day. As a result, your fat cells stay locked while those molecular scissors remain completely unused. This explains why a calorie deficit on paper does not guarantee actual fat loss. Your body does not only respond to calorie math written on paper somewhere, it responds primarily to hormonal signals, and hormones currently might be shouting, "Store everything." The second critical biological switch controlling this entire process involves the hormone leptin directly. Leptin gets released mainly by your fat cells as a constant status report. Think of leptin as a daily energy report being sent straight to your brain. When your body holds more stored fat, leptin levels typically rise correspondingly higher overall. Your brain receives a clear message that energy reserves remain perfectly stable and sufficient. But when you begin losing weight, your fat cells shrink and leptin levels drop. This is exactly when things can start feeling uncomfortable and frustrating without any clear reason. You might look in the mirror thinking progress is happening exactly as planned, but your ancient survival brain may interpret falling leptin completely differently than you expect. To that primal brain, falling leptin might signal dangerously low energy reserves ahead, so your body begins adjusting immediately, increasing hunger signals and constant thoughts about food. Your energy drops noticeably, workouts feel significantly harder, and your weight loss may suddenly stall. This absolutely does not mean you are weak, lazy, or lacking real discipline somehow. It simply means your biology is doing exactly its intended protective job correctly. Picture your belly fat maintaining a private group chat conversation with your brain constantly. In that chat, fat cells continuously report current energy reserve status back to headquarters. Meanwhile, your brain decides whether the body should burn more energy or conserve it. Sustainable fat loss, therefore, is not only about forcing yourself to eat drastically less, it involves helping your brain feel genuinely safe enough to avoid early panic mode. Sleep is honestly one of the biggest hidden factors influencing this entire leptin process. When you sleep around 7 to 9 hours consistently, something remarkable happens internally. Your brain gets a much clearer chance to read leptin signals accurately overnight. It becomes almost like receiving an important energy report without any annoying background static interference. But when you sleep too little or wake up frequently throughout the night, everything changes. That crucial signal begins getting distorted, confusing your brain about actual available energy reserves. When your brain becomes genuinely unsure, it typically chooses the safest possible protective option available. It increases hunger signals, lowers energy expenditure, and pushes you toward higher calorie foods. This explains why, after one terrible night of sleep, cravings suddenly feel completely uncontrollable. You crave bread, sweets, sugary coffee, or literally anything promising quick, immediate energy replenishment. Poor sleep also makes basic daily tasks like walking or meal prep feel exhausting. At that exact point, weight loss stops being logical and becomes an emotional battle, a battle between your weakened willpower and hunger hormones screaming loudly for immediate attention.
So please stop treating sleep as some minor afterthought within your overall weight loss strategy. Treat it instead as a critical hormonal switch deserving genuine, consistent, daily priority attention. The third major biological switch involves something scientists now call fat cell memory itself. This concept explains why the frustrating yo-yo effect feels like personal biological betrayal sometimes. When you lose weight, your fat cells shrink noticeably, but they do not forget completely. Emerging research suggests fat cells may retain certain biological markers, almost like permanent notes. Notes recording the largest size or highest weight your body ever previously reached. Picture a fat cell like a balloon once inflated to an extremely large size. When you release some air, it shrinks, but the material remains permanently slightly stretched. It does not instantly transform back into a completely fresh, brand new balloon somehow. So after reaching your goal weight, relaxing too quickly becomes genuinely dangerous territory here. Eating irregularly, sleeping poorly, or returning to old stressful habits creates a specific risk. Those slightly stretched fat cells may refill surprisingly fast under these exact conditions. This explains why people lose weight over many difficult months, yet regain it shockingly fast. The critical insight here is that maintenance is not some relaxing victory lap afterward. It represents an entirely separate biological project, especially during your crucial first 12 months. This becomes the specific period where you actively teach your body the new weight feels safe. And here comes a genuinely surprising twist that catches most people completely off guard. The most dangerous moment is not actually while you are actively losing weight. It happens afterward, once you have already successfully lost the weight you wanted. That sounds completely backward considering everything you dieted for and worked so hard achieving. You walked daily, controlled your eating carefully, and watched that number steadily decrease over months. So why does your body still refuse treating this moment as final, permanent victory? The answer lies directly within fat cell memory after reaching your specific target weight. Your fat cells have genuinely shrunk, but they have not fully forgotten their previous size. They resemble empty warehouses that stood filled for years, now quietly watching your behavior, watching closely to see whether you eventually return back toward old familiar habits again. This is precisely the part you should never skip or underestimate during your journey. Maintenance is not some reward you receive after finishing weight loss successfully. It represents the actual phase where you retrain your entire biological system completely. During those crucial first 12 months, your body continues adjusting hunger hormones and metabolism. It readjusts leptin signals, insulin response patterns, and your completely new energy balance system. If you celebrate too early and loosen every single habit completely and immediately, watch out. Fat cells may interpret this sudden change as the perfect signal to refill quickly. So how exactly do you navigate this phase without living in constant, exhausting fear? The answer involves consistent stability rather than an even stricter, more punishing diet approach. Reasonable meals, consistent movement, adequate sleep, and stress management all matter here immensely. Your journey genuinely is not finished once that scale number finally drops significantly. You have simply entered the most important chapter yet, teaching cells to forget permanently. The fourth biological switch involves understanding the crucial difference between subcutaneous fat and visceral fat. This distinction matters enormously because not all body fat behaves identically inside your body. Subcutaneous fat sits just beneath your skin, the kind you can physically pinch easily.
It affects how you feel about your body shape, but remains relatively less dangerous metabolically. Visceral fat behaves completely differently, sitting deep inside your abdominal cavity surrounding vital organs. It surrounds your liver, intestines, pancreas, and other absolutely essential organs your body needs. Here's an important question worth genuinely considering carefully before moving forward together. If two people weigh exactly the same, why does one face higher health risks? The answer lies specifically in the location and behavior of this particular fat type. Visceral fat is not simply passive energy storage sitting quietly somewhere inside you. It functions more like an active inflammatory signal station hidden deep within your abdomen. It constantly sends disruptive chemical messages throughout your entire body system continuously. Even more importantly, visceral fat releases fatty acids directly into your portal vein system. This creates almost like a private, direct pipeline connecting belly fat straight to your liver. This is the crucial part many people accidentally skip, yet it matters tremendously overall. Visceral fat does not simply make your belly appear larger than you want. It forces your liver to process excessive incoming fuel, disturbing blood sugar and insulin. So reducing deep belly fat specifically is not just about achieving a smaller waistline. It genuinely reduces pressure on your liver, pancreas, blood vessels, and entire metabolic system. Why exactly does visceral fat harm your liver more than regular subcutaneous fat does? The answer again lies specifically within its unusually close proximity to vital organs. Subcutaneous fat sits farther away from your body's primary metabolic processing organs entirely. Visceral fat sits extremely close to your liver, intestines, and pancreas simultaneously and constantly. When this fat type releases fatty acids, they travel almost instantly through the portal vein. This creates a private highway carrying fuel directly from your belly straight toward your liver. If your liver keeps receiving excessive fatty acids from visceral fat constantly, problems emerge.
Your liver must process this excess fuel while simultaneously managing blood sugar and cholesterol. When this pressure continues for extended periods, blood sugar becomes increasingly difficult to stabilize properly. Blood fats rise more easily, insulin works overtime, and metabolic dysfunction risk increases significantly. This is genuinely the part you absolutely should never skip or ignore completely. Body weight alone does not determine your overall health status accurately or completely. The specific location of your fat matters tremendously more than most people ever realize. So reducing deep belly fat specifically helps your liver breathe easier and function properly. The fifth biological switch involves adrenaline receptors and how they respond throughout your body differently. Most people assume adrenaline simply makes your heart beat faster during stressful moments, but inside fat tissue specifically, adrenaline sends remarkably different messages depending on receptor type activated. Some receptors function like open doors, helping fat cells release fatty acids for energy. Other receptors function more like locked doors, keeping fat completely trapped inside cells instead. Here comes another genuinely fascinating twist worth understanding clearly before we continue further together. When you live under chronic stress constantly, tense, sleeping poorly, and worrying excessively daily, watch closely. Stress signals can get pushed in completely the wrong biological direction entirely and consistently. Instead of helping mobilize energy intelligently, your system shifts dangerously into full defense mode instead. This happens especially around stubborn visceral fat specifically, making everything significantly more difficult overall.
In simple terms, chronic stress does not just make you feel emotionally terrible constantly, it genuinely makes deep belly fat considerably harder for your body to unlock. This is exactly the part most people completely miss during their weight loss journey. You might eat less and exercise more, doing everything technically correct and disciplined, but if your nervous system keeps hearing constant alarm sirens, nothing meaningful actually changes. That is precisely why stress management represents a genuine fat loss strategy, not luxury. Sleep more consistently, walk gently outdoors, breathe slowly, and rest during appropriate recovery moments regularly. Help your body understand it genuinely does not need locking fat storage for survival. So how exactly do you make stress hormones open doors instead of locking them shut? The answer definitely is not eliminating all stress completely from your daily life entirely. Your body does not need some perfectly calm, stress-free existence to function properly overall. It needs to distinguish clearly between healthy movement stress and genuine dangerous survival alarm signals. When you train at reasonable intensity, sleep enough, eat consistently, and recover properly, everything changes. Exercise stress becomes a genuinely positive signal telling your body to become stronger overall. But if you have slept poorly, worked yourself into exhaustion, and forced brutal nighttime workouts, beware. Your body may interpret this situation as being attacked from every possible direction simultaneously. At that exact point, stress hormones stop supporting metabolism and instead become blaring alarm sirens. These sirens make your body cling tightly onto stored energy reserves instead of releasing them. That is precisely why pairing intense training with adequate recovery represents the smarter overall strategy. Some days involve harder training sessions, while other days require gentle walking and slow breathing. This includes stretching, earlier consistent sleep, and reducing stimulation from phones, news, and caffeine intake. This part genuinely deserves remembering throughout your entire fat loss journey moving forward. Fat loss does not only happen when you push yourself harder every single day. It also happens when your body feels safe enough allowing this process continuing naturally. You do not need a completely stress-free life to successfully achieve your fat loss goals. You need teaching your body that movement represents a healthy signal, not dangerous crisis. The sixth and final biological switch involves cellular recycling that activates specifically during extended fasting periods. This represents a deeper mechanism than simply burning fat for immediate available energy needs. When you stop eating for sufficiently long periods, your body eventually realizes no new energy arrived. At this specific point, it stops relying solely on cutting triglycerides for fatty acid release. Some cells actually activate an internal cleanup and recycling system entirely different from normal burning. This functions almost like a dedicated biological cleaning crew checking your entire storage room thoroughly. This crew collects old, damaged, excess, or unnecessary cellular parts and reuses them efficiently. This particular mechanism moves slower and deeper, never activating simply because lunch arrived late somehow. It typically requires sufficiently long periods without food for this genuine metabolic shift occurring. Picture your body as an enormous house, constantly receiving new deliveries throughout each day. When you keep bringing new items constantly inward, nobody finds time cleaning storage rooms properly. But when incoming flow finally pauses temporarily, your body starts examining everything currently stored carefully. It asks what can genuinely be recycled, reused, or removed entirely from cellular storage.